Geometry CNA students. Today we're going to be taking a look at page 476, notes. So let's jump in. So again, the PDF is at the top. If you want to take a look at that and print it off in advance of completing the notes, that's totally fine. Today we're going to be talking about the area of a circle. Area of a circle. The area A, capital A, of a circle equals pi times the radius r squared. So A equals pi r squared. Examples. Number one, find the area of the circle. So you see the circle here, which highlights a diameter of 13. In this case, because r can be then calculated by dividing both sides of this equation by 2. So dividing 13 by 2 lends itself to that particular radius. So 13 over 2 is the radius, 13 halves. Plug it into the formula, A equals pi r squared. So you have pi times the quantity 13 halves squared. And if you do the math on 13 halves quantity squared, you'll end up with 42.25. And that calculates out such that you get 132.73. If you multiply by the pi button on the calculator, you'll end up with this. The area of the circle is about 132.7 inches squared. I'm going to take a look at the calculator and see what that ends up giving us more precisely in a moment. So let's take a look on the calculator. So again, it was 13 halves quantity squared. Notice I am using parentheses. Now, if I use 3.14, that's not as accurate as using the pi button. So I'm going to use pi instead. Second caret key gives me the pi button. And there it is, 132.73. According to what they gave us, 132.73, which is a good final answer, I would argue, rounded to the nearest tenths, 132.7 inches squared is acceptable. Another version of this that would be acceptable is the following. So let's say I just typed in just 13 halves squared and 42.25. Okay, so the calculator was correct, as was the note sheet in that particular step. So this is another version of the answer that would be acceptable. And I would go as far as to maybe rewrite that as a fraction. Math, convert to fraction. So 169 over 4. Just to kind of keep your options open. This is in terms of pi. In this particular case, the decimal version is just as good. Example 2. Find the area of the shaded region. Assume that the smaller circles are congruent. So first, find the area of the larger circle, and that's as easy as pi r squared. So area equals pi. This is the radius of the larger circle. I'll call it r sub 1, in which then you do pi times 20 quantity squared. And that ends up being 1256.64. And then each respective smaller circle, because each radii is 6, we'll call it r sub 2, and there's 3 of those. We'll see the math unfold in a moment, but just one of those circles in particular, if you plugged in 6, you'll get 6 squared times pi, or 113.1. So again, because there's 3 of those smaller circles, we'll have to take that into account in the next step. So finding the area of the shaded region works out as such. So we'll take the area, I'll label it a sub 1 maybe from up above and a sub 2 from up above. So if I subtract a sub 1 minus 3 times a sub 2, again, there's 3 smaller circles, so that makes sense. That then lends itself to 339.3. If you subtract those, you'll get the final area to be 917.34 meters squared. So all of those answers respectively, I'll go back and highlight. Okay, let's move on. The same types of problems we're about to take on here. Find the area of each circle to the nearest tenth. So number 1, A equals pi times r squared. So that's pretty straightforward. I would argue, again, r, I didn't label it, let me do that, being 7. So it makes sense then, of course, of pi r squared, or pi times 7 squared. I can simplify after this step. 49 pi actually wouldn't be a horrible answer in some instances. as a decimal approximation, because yes, the directions did say round to the nearest tenth. Go that extra step and type in 49 pi. And we're looking at 153.9. All right. And that is feet squared. Let's do number 3. So for this particular problem, we're looking at the diameter. Remember that the diameter is twice the radius. So if I use what? 15 equals 2 times r, I know then that the radius is 15 over 2. So simply capital A, or A equals pi times radius squared. Okay, so for the sake of kind of what we saw in the prior few questions, we can simply type in, and I'll do this separately, 15 halves quantity squared first. So that can be maybe rewritten as such, 225 fourths pi. That's a solid answer, actually. I would accept that. If the question didn't specify how to round it, if to round it, and how. That's a good answer, but of course, because they asked for that, we're going to multiply our answer times pi. And that then lends itself to 176.7. And that's yards squared. Okay, let's finish up with the last little section. Find the area of each shaded region to the nearest tenth. So the first picture that you see is a circle, of which represents, well, concentric circles, right? We have got a larger circle and a smaller circle, of which share the same center. The radii are obviously different. So we've got an r sub, let's say 1, and we've got an r sub 2, respectively 16 and 8 inches. To find the area of the shaded region, we're going to do it to the nearest tenth again. We're going to have to do some subtraction here. So the area of the larger circle, that would be obviously a bigger value. So let's do that first. A sub 1, let's say, is equal to pi times that radius squared. We'll find that in a moment. A sub 2, not surprisingly, will be a smaller area. So pi times that radius squared. So that's pi times 8 squared. This ends up being 16 squared pi, which is 256 pi. And the other being what? 8 squared. So we know that, of course, is 64. So 64 pi. And if we subtract these two, quite simply, actually, will boil down to 256 minus 64. They're quote-unquote like terms. And then we can continue with 192 pi as one version of the answer. But of course, we have another version where if we multiply by pi, 603.2. And that's inches squared. Let's continue with number 5. Same premise, we're trying to find the shaded region area. But if you take a look here, we've got what appears to be a rectangle with end aspects here, of which are circles. I say end aspects. We can see here that the diameter of each circle essentially is the representation of the, let's just say, width of the rectangle. So the rectangle, we can actually calculate separately, area-wise on its own, we can calculate separately, in which that would be what? Length times width, so 50 times 20. That's not too difficult, of course. We can multiply 50 times 20, and we've got that, 1,000. Okay, so 1,000 centimeters squared. That is the area A sub 1 of just the rectangle. Now, because we want the shaded region only, think about what we've got. We've got two circles, of which the semicircles, essentially here and here, we can together come up with areas of. We can find the area of one circle and then the other, and then we'll divide each by 2, or we can just find the area of one of these circles because, well, combined, these two blue semicircles add up to one circle. So let's do maybe A sub 2 as such. We'll say area equals pi times the radius. Now be careful, the radius is not 20, of course, it's 10. So we'll use pi times 10 quantity squared. And if we do that calculation, that might be the easiest one, 100 pi. We'll use that in conjunction now with the a sub 1 that we came up with, wherein, because again, we want the area of just the shaded regions, subtract off the blue semicircular regions, which again add up to a combined 100 pi. And then you have it. So let's do that. Let's do a sub 1. Write it up this way, minus a sub 2. We got 1,000 minus 100 pi. And that should be, we'll do this on the calculator without any other analysis. And let's see. To the nearest tenths place, we're looking at 685.8. We are in centimeters squared. That should do it today, folks.